powers of I, folks. Back to basics. Let's see what's going on here. I'm going to write I to the 1, even though we don't, but on purpose I'm going to write I to the 1. It's simply I. And I squared is simply -1 by definition. I to the 3. What can I do this? Well, we can apply the exponential rules when we are multiplying two things with the same base. What do? We simply add the exponents. On the multiplication, the same base, we add the exponents. So we're going to use the same trick here. I to the 3, I'm going to break it down as I squared times I to the 1. Same base, we add the exponent. 2 plus 1 equals 3. But we know that I squared, how much is I squared? -1. And I know that I to the 1 is simply I. So -1 times I, -I. And I to the 4, I can use the same strategy as before. We can break I to the 4 as I squared times I squared. But I squared, of course, is -1. I squared is -1. Last time we checked, -1 times -1 is +1. Okay. What happens if they ask us to find I to the 5? Just right here, I to the 5. Space. I can use the same trick as before. I can do I to the 4 times I to the 1. But I to the 4 is 1. I to the 1 is simply I. 1 times I. I believe hopefully you see what's going on at this point. If not, let's go ahead and continue. I to the 6, I can break it down at I to the 4 times I squared. I to the 4 is 1 times I squared, which is -1. This guy will be -1. If we continue with this pattern, I to the 7 is going to be I to the 4 times I cube. I to the 4 is 1. I to the cube is -I, so this guy will be minus I. And I to the 8, I can break it down as 4 plus 4, which is 1 times 1, which is 1. Same pattern as before. Okay. Now I'm going to piggyback on this, so you see how the pattern repeats. Let's go ahead and find I to the 9. I'm going to write here, I'm going to find I to the 9, 10, 11, and 12. But 9 will be 8 plus 1. But I to the is 1, so it's I. 10 will be 8 plus 2, right? So 1, whatever. 11 will be 8 plus 3, but I to the 8 is 1, so blah. I to the 12 will be I to the 8, and my answer is 1. Now, the same pattern. Okay, so hopefully you got the ideas. If I were to find I to the 13, I'm going to find 13, so it will be 12 plus 1, 14, 12 plus 2, and then the same pattern happens. Bottom line, what can we conclude? That every time we hit multiples of 4, we restart the pattern. With that in mind, if I were to ask you, let's go ahead and find I to the 25. So it will be the closest multiple of 4 with 25. That will be I to the 24. 24, 6 times 4 is 24. This is a multiple of 4, so it will be 24 times I to the 1. 24 plus 1 is 25. This puppy, I know this is 1. And how much is I to the 1? Simply I, and we are done. Okay, let's try a couple, 2 more. Just this chunk. If I ask you to find I to the 50. Okay, so let's go ahead and find the closest multiple of 4. That will be 48. 12 times 4, that will be 48. And that will be I squared. I to the 48 is 1. It's a multiple of 4. How much is I squared? -1. Okay. If I do I to the 99, this will be I to the 96 times I cube. I to the 96 is multiple of 4, so that's 1. And how much is I cubed? Negative I. We're done. So we're to ask you how much is I to the 108. Well, 108, we already know that 108 is a multiple of 4, so this is just simply 1. And we are done. How do I know the multiple? This is done, but how do I do the multiples? You can always use long division. Let's say that I'm going to do 99. 99 divided by 4. 4 fits into 9 2 times. This time that is 8, raised to 1. Drop the 9. This fits in, how many times 4 fits into 19? That would be 4 times, no, 3 times. 4 times 5 is 20. 4 times 4 is 16. Reciprocal 3. Okay? So I don't really care about the 24. Well, 4 times 24, that would be 96. But this is what I care about, the reciprocal of 3. The remainder 3, which is the exponent that I need here. I only look at the remainder, and this is the one that will dictate which of the 4 i's will I use. This is I cubed, so this is negative I. Hope this helps.